Hello, doctor. My name is Wan Kang. My MAC number is 204876. This short video is for SSK3003. My topic is arrangement and selections without repeat. So let's see the PowerPoint. This is my topic, arrangement and selections. Well, first, we should know history. In the 17th century, the French mathematicians Blaise Pascal and Prat de Fermat gave impulse to the growth of combinators and probability series by considering the ratio of the number of desired subsets to the number of all possible subsets for many games of chance. The left one is Pascal, and the right one is Fermat. Well, we divide them in permutations and combinations. The different way in which usually without replacement. Objects from a set can be selected to form subset. When the order of selection is a factor, this selection of subset is called a permutation. When the order of selection is not a factor, this selection of subset is called a combination. Okay. And then the left one is permutation equation. The right one is combination. And we write P, R. C means combination, P means permutation. Okay, let's see the example. The first example about permutation, the word Python have 6 letters. How many permutations without repetition are there if you choose 6 out of 6 letters? This is P, which we put the permutation equation in there, right? And N is equals with 6. R is equals with 6 too. So P 6 and it's equals 6 factorial divide 0 factorial, and last is equals with 720 ways. And the next example is about combination. First, we can divide it, and there are 6 men and 5 women in a room. In how many ways we can choose 3 men and 2 women from the room? First, we can divide them in 2 questions. The first one is 3 men from 6 men. And the second one is 2 women from 5 women. And then we multiply by it, right? Is C 6 3 multiplied by C 5 2, and then we put the equation. The last is 20 multiplied by 10 and equals with 200 ways. Okay, it's easy to understand. Well, I would like to say the importance of permutation and combination. Permutation are important in material of counting problems as well as in various other fields of mathematics. Permutation are often used to define determinative. For example, combinations are important in selecting the elements easier without arrangement and repetition. That's all. Thanks for watching. Bye.
Assalamualaikum warahmatullahi wabarakatuh, and hi guys, my name is Muhammad Izrin Shafiq bin Ahmad Jalil and my metric number is 206845. In this video, I want to explain about the Fibonacci relations and its application. Let's go. In this video, I want to explain about the Fibonacci relations and its applications. Let's go. So, what is exactly means of Fibonacci sequence? Do you guys know about this meaning? Let me explain. So, the definitions of the Fibonacci sequence is defined as F0, F1, F2 until Fn by initial conditions F0 equals to 0, F1 equals to 1. And we can relate that the recurrence relations is Fn equals to Fn minus 1 plus Fn minus 2. You guys need to remember this equation because in this topic we're gonna use this equation a lot. So let's go to the next slide. So I will explain about the example 1. So find the Fibonacci numbers F2, F3, F4, F5 and F6. So how do we gonna solve this problem? So in this question, we need to remember about the formula Fn equals to Fn minus 1 plus Fn minus 2, and also the initial values F0 equals to 0, F1 equals to 1. So we need to find the F2. We know that F0 equals to 0 and F1 equals to 1. So we need to use the formula just now, Fn equals to Fn minus 1 plus Fn minus 2 to solve this problem. So we need to find the F2 first, and we use the equation to solve this problem equals to 1. So and also do it again until F6. Let's move on to the next slide. So what is exactly the applications of Fibonacci sequence? If you guys have an idea, please put in the comment down below. So what is the exactly applications of Fibonacci sequence? So there is a lot of application that we can use from this Fibonacci sequence. For example, the petals on flowers, the Fibonacci number in Pascal triangle, Fibonacci in music, and also Fibonacci in coding. There is a lot, many applications of this, but I'm gonna show these few applications in this. But in this video, I just want to focus on the most popular application, which is the rabbits and Fibonacci number. So, can you guys imagine how this Fibonacci sequence can be applied in this problem? So, a young pair of rabbits, one of each sex, mean male and female pet, is placed on an island. A pair of rabbits does not breed until they are 2 months old. After they are 2 months old, each pair of rabbits produces another pair each month. So, the highlight from this question is after they are 2 months old, which means that after 2 months they will produce another pair. Which means that after 2 months they will produce another pair, which is male and female, as shown in the picture below. I will show it later. So the problem is find the recurrence relation for the number of pairs of rabbits on the island after n months, which means that we don't know until what month. Assume that no rabbits ever die. So I'm gonna give you tips how to solve this problem. So for the first month, there is 2 rabbits, which means that 1 pair. For the first month, we have total pairs of 1. So the next month, we have the same amount of pair, which is 1, because we need 2 months old. Then they will produce another pair. But this is only 2 months, so we need another month to produce another 1 pair. So for the next month, you can see that there is create 1 more pair because it said after 2 months old. So this is 3 months. So we can see that the rabbits is produced 1 more, which is equal to 2. And after that, we can see this rabbits produce 3, then it's produced 2 after 5th month, which means that after 2 months more, we produce 2, and this one is produced more 1. We can see that from this application, we can see that it's suddenly exponentially increase. So, and for the last month, 6th month, we can see that it's produced a lot of pair of rabbits. You can see here. So how do we gonna solve this problem? You can see that, right? How the question is going. So the solution is, let Fn be the number of pairs of rabbits after n months. Fn equals to 1, then n equals to 1, 2, 3 until n are the terms of the Fibonacci sequence. So F1 equals to 1 pair of rabbits on the island at the end of the first month. F2 equals to 1 pair because the pair does not breed during the first month because it needs 2 months. So to find the number of pairs of the island after n months, add the number on the island after the previous month, Fn minus 1, and the number of newborn pairs, which equals Fn minus 2 because each newborn pair comes from a pair at least 2 months old. So in conclusion, we can say that consequently the sequence Fn satisfies the recurrence relations. Fn using the formula Fn equals to Fn minus 1 plus Fn minus 2 for n at least 3 with the initial conditions F1 equals to 1 and F2 equals to 1. The number of pairs of rabbits on the island after n months is given by the nth Fibonacci number. And I hope you guys can understand this problem. So thank you for those who are watching. Let's continue to our next presentations.
Hello doctor, my name is Mayuze. What I'm going to talk about today is the tower of Hanoi. Its context is very simple. Let us take a look.
Yeah, the topic is the Tower of Hanoi. And the Tower of Hanoi is an education toy based on an ancient Indian legend. And the problem with the Hanoi Tower is that there are three clocks on the bottom board, and the 3 discs are placed on column 1 with the small one on the top and the largest one on the bottom. Ask the participant to move the 3 discs on column to the column 3. The conditions is only 1 disc. Any columns can be moved at a time, but the bigger disc cannot be placed on the small disc. The Tower of Hanoi is composed of 3 blocks A, B, and C. There are unperforate discs on rod A, and the size of the discs becomes similar from bottom to top. It is required to move all the discs to the C bar according to the following rules. Only 1 disc can be moved at a time. The largest discs cannot be stacked on the small disc. Tips: the disc can be temporarily placed on the B bar, or the disc removed from the A bar can be moved back to the A bar, but the above 2 rulers must be followed. The question is how to move. How many times should I move at least? Yes, and thank you for watching.
We can see that there's 4. Let we do that.
Hello doctor, my name is Lihongshen and my micro number is 208788 and I will talk about compound interest. Hello everyone, today I will introduce money growing in a saving account and we also can call it compound interest. And first we should to know what is compound interest. Compound interest is the addition of interest to the principal sum of a loan or deposit, or in other words, interest on interest. It is the result of reinvesting interest rather than paying it out, so that interest in the next period is then earned on the principal sum plus previously accumulated interest. Compound interest is studied in finance and economic. When we know what is the compound interest, let's see this question. We solve this question. And first, we let Pn denote the amount to pay back after 5 years, and Pn satisfies the following recurrence relations, and we can get this formula. And PO equal 50,000. And then we using forward substitution, and we can get Pn equal 1.1 to the power of n 50,000, and we can get P5 equal 80,525.5. And let's see this. Mathematical formula for calculating compound interest depend on several factors. These factors include the amount of money deposit, called the penalty, or the annual interest rate, and the number of years the money is left in the bank. These factors lead the formula. Then we can get the formula. FV equal P1 plus to the power of n. And FV is future value, and P is principal, and I is the annual interest rate, and N is time in years. Let's see the question 2, and we get 2 solutions. The first solution is like question 1. We use the recurrence relation and get Pn equal 1.03 to the power of n PO, and we know P30 is 3 million, so we can get PO. The solution 2, we just need to use FV equal P1 plus R to the power of n, and we know we let FV is 3 million, and then we can get P. That's all for compound interest. Thank you for watching.